Okay, chemical formulas and how to write those. Basically, a chemical formula is an example right down here at the bottom. It's a combination of symbols from our periodic table and then subscripts. These little numbers right here are subscripts, okay, and we use those in various ways. A formula unit is just this whole thing. We will also see molecular formula, basically the whole thing. And then a polyatomic ion is a combination of nonmetals that have a charge, and we'll talk about those a little bit more later also. Um, just real quick reviews, monatomic ions. These are just when we talk about a metal by itself or a nonmetal by itself. So here, a single atom, mono means one. Here, cations, again, remember cations are going to be positive, and they're just the name of the element. So potassium cation here. Anions are going to be negative. You can see here that it's got a negative sign. Here they have an ending of IDE, so this is a fluoride anion. And that's the way it'll be all the time, is the metal is just its name, and then the nonmetal is an IDE ending. We do have 7 diatomic molecules. You need to remember these right here. They basically make a little 7 in the corner of your periodic table, starting with nitrogen and going over and down to iodine, and then remember that hydrogen is over here on your periodic table. So there's 7 of them. They make a little 7 in the corner, again starting at nitrogen, going down to iodine, and then the 7th one is actually hydrogen up there by itself. So remember, anytime you see these elements and they're by themselves, for example, hydrogen gas, oxygen gas, nitrogen gas, they are always going to be 2. Di means 2. So there's a 2 subscript for all of those. Oxidation numbers, again, just a quick review. Remember, when you're in group 1, you're going to lose an electron, so it's positive 1. Group 2, lose 2, so it's positive 2. Group 17, you gain 1, so it's negative 1. Group 16, you gain 2, and etc. So that's just a quick review. You guys should remember that as much as we've done that. Again, remember the charges are called oxidation numbers. Any pure element, so just sodium by itself or I2 by itself, the oxidation number is going to be 0. Whenever we write a formula, the sum of the oxidation numbers must also be equal to 0. And we're going to be doing that a lot more here as we practice this. Okay, so binary, bi means 2. So binary ionic compound, so this is going to be a metal and a nonmetal. So things to remember there again, ionic is always a metal and a nonmetal combined together. Okay, we're going to have a positive part, which is your metal, and a negative part, which is your nonmetal. Okay, so here you can see magnesium has a positive 2 charge. So if we want to cancel out this positive 2 charge and chlorine only has a negative 1 charge, we need 2 chlorines to cancel that out. Again, your total charge in your whole formula must be equal to 0. We can use what is called the crisscross method. And if you look down here, you can see that calcium has a plus 2 charge, so that ends up being the subscript for chlorine. Chlorine has a negative 1 charge, and so we don't write anything if it's a 1, but that ends up being the subscript for calcium. So that's an easy way to do binary compounds. Now the stock system, here we use Roman numerals. What this means is if we have a transition metal, they have more than 1 charge. So we use a Roman numeral here to indicate that in this compound, copper's charge is positive 2. So if we're going to write out this formula, we know copper has a plus 2. We know chlorine is negative 1 because it's in group 17, so we're going to have 1 copper and we're going to have 2 chlorine. Another way of thinking about it is writing out that second chlorine. Copper is going to give 1 of its valence electrons to this chlorine because it has 2. This chlorine needs 1, so copper is going to give the other one to there. So you need 2 chlorines and 1 copper. Okay, again, transition metals have more than 1 charge. Okay, so you should be able to look at a formula like this and figure out what the charges are. If we look at oxygen, we know that oxygen has a negative 2 charge. If there's only 1 iron with that oxygen, we know it has to be equal to 0 altogether, so this charge has to be plus 2. So we would write this as iron 2 oxide. In this case, oxygen, again, is always negative 2. Okay, negative 2. There's 3 of those. And so -2 plus -2 plus -2, this pen, is -6. Okay, so if we have a -6, then we know we're going to need, I don't know what's going on, you guys. We know that we have to have 2 of these. Okay, so +3 plus +3 would give us a +6. And we just said if oxygen is -2 and you have 3 of them, -2, -2, -2 would give us a -6. And so those would cancel out. Okay, so this would be iron 3 oxide because we know the charge here has to be +3 to only have 2 irons here. Okay, and so we'll do some more practice with that also. Again here, oxygen is -2, so that means chromium has to be +2, so that's why there's a Roman numeral 2 here. Each chlorine has a -1 charge. There's 3 of them, so chlorine's -1, -1, and -1. So that means to get a total, it would be -3. We want to cancel that -3 out, so chromium has to have a +3, so that's why there's a Roman numeral 3 here. Sulfate is a polyatomic ion. It has a -2 charge. Again, there's 3 of those. So we have one -2 charge, a second, and a third, because right here, this tells us we have 3 of whatever's inside of here. This whole thing has a -2 charge, so that would give us a total of a -6 charge. There's only one chromium, so that tells us chromium has to be +6, and so we would use Roman numeral 6. Bromine, each bromine has a -1 charge. There's 2 of them, so we know we have -2, so cobalt has to have a +2 charge. Okay, so that's an example of how you figure out your Roman numerals when you have a transition metal. Okay, so again, things to remember: the Roman numeral matches the charge on the metal, and the charges when added together must be equal to 0. 2 things that you have to remember.